Okay, Oak Rovers, this is a video that's going to help you with tomorrow's lesson, which is going to be on 3.1.2, and then we're going to skip 3.1.3 and go right to 3.1.4. I think you have three problems on 3.1.2, 10, 11, and 12. So problem 10 reads like this. John's Giant Redwood Tree, Part 1. John found the data in the table below about his favorite redwood tree. He wondered if he could use it to predict the height of the tree at other points of time. Consider this as you analyze the data and answer the questions below. Be ready to share and justify your answers with the class. So next they have a table, and they have the table for your years 3, 4, and 5, and they give you the heights for those years. And you want to think of your years is going to be your time or your independent variable, and that's going to be on your x-axis, and the height of your tree is going to be on your y-axis. And you'll see that in a little bit when we get to the lab sheet that you'll use. Then it says, how tall was the tree 2 years after it was planted? So if you notice, the one variable is the number of years after planting. So 3 years after it was planted, it was 17. 4 years after it was planted, it was 21. They want you to predict how tall it was 2 years after it was planted. And then again, at 7 years after it was planted, and then explain how you know. Okay, after you get done with that, then they ask, how tall was the tree the year it was planted? So when trees are planted, they're going to be a little bit off the ground. You got to figure out how tall that tree was as it was planted, because trees are not planted underground. And then it says, estimate the height of the tree 50 years after it was planted. How did you make your prediction? So maybe there's going to be a way that you can explain that rather than continue the table all the way up to 50 years. They're going to give you a lab sheet, and this is what the lab sheet looks like. And I'm going to show you how you can get that lab sheet when you're at home. It said John decided to find out more about his favorite redwood tree by graphing the data. On lesson 3.1.2b resource page provided by your teacher, plot the points that represent the height of the tree over time. What does the graph look like? So you're going to have to answer all these questions, A, B, C, and D. Now if you ever want to get a lab sheet at home, what you can do is you can go to cpm.org. That's cpm.org, and you'll come to this page. It looks like this, and I've highlighted the student resource pages. So you'll click on that highlighted part there, and then it's going to bring you to a page that looks like this. The course you want to pick is Algebra Connections, and you're going to want to go to Chapter 3, and then you'll pick out the section that you're on that lab sheet. Okay? And your lab sheet that you'll have is going to look just like this lab sheet here. So what you're going to have to do is fill out the table, and after you fill out the table, you're going to have to make the graph, and then also give a rule. That's going to be part of that lab sheet. Okay? So then you get to part number 12. John is still not satisfied. He wants to be able to predict the height of the tree at any time after it was planted. Find John's table on your resource page and extend it to the height of the tree in 0 years, 1 year, 2 years, 6 years, and 7 years. Okay? You can skip problem B from this section. You can just kind of skip that. But if you're not, well, one second. If you've not already, from the ideas from the silent board game, write an algebraic rule for the data on the table. I want you to write that rule, I guess. So you're going to find that rule and write that rule. And then from that rule, you're going to predict how tall that tree would be in 50 years. Okay? And that's going to be what you're going to do on 3.1.2. Then we're going to go all the way up to 3.1.4, and we're going to go to the second problem, it says. And it says, 33 says, use the rule y is equal to 2x plus 1 to complete the table in A. And then examine the numbers in the table. What are the greatest x and y values in the table? What's the smallest x and y values in the table? And you're going to use that information to set up a graph. Okay? Use this information to set up x and y axes that are scaled appropriately. And then you plot the points and make a graph. That's what you're going to do for 33. You're going to continue this with a new equation on 34. Now the equation is y is equal to negative 3x plus 1. So what you'll do is, if x is negative 4, negative 3 times negative 4. Just remember, negative times a negative is positive, plus 1, and you should get to 13 there. Negative 3 times 3 is 9. Plus 1 will be 10. And you can continue to make that table. And then after you do that, make the table, you're supposed to graph it. on a new set of axes, so you'll need some more graph paper. And you can come into the graph paper section and do that in my classroom. Then you have to ask how the graph is similar to the graph in problem 33 and how is it different. So they want you to have both graphs, and when they do the graph, it's not a sketch. They want you to actually use a ruler and make the graph as neatly as possible for both of those problems. And actually all problems that we do here. So try and make those graphs as nice as possible. Then you're going to go to 35, and they'll have a new type of graph. The y-axis, calculate the y values for the rule y is equal to x squared, and complete the table below. Now remember, x squared means x times x. So if x is negative 4, it's negative 4 times negative 4. If it's negative a half, it's negative half times negative a half. And what you have to remember with this is when you multiply a negative times a negative, like negative a half times negative a half, you're going to get a positive value. So they want you to actually find these values, and then you're going to have to examine the x and y values in the table, use this information to set up a new x and y axis that are scaled appropriately, plot the points on your graph, and then label your graph with its rule. Now 4 times 4 is going to be 16. So your y value has to go at least to 16. Negative 4 times negative 4, well, a negative times a negative, remember, is a positive, and that goes to negative 16 too. So you're going to have to graph that, and then they explain this new shape that you just graphed in problem 35 is called a parabola. So then you can read about those parabolas in the math notes books. And if you haven't done so already, if you want to do that, that might be a good thing to do tonight also. So you get your homework done and then you can graph that. And then the vertex of the parabola, they're going to talk about vertex in that math notes, and you can kind of answer that as well. After you get done with that, that's the last part actually of your classwork. I'll have a few different homework assignments that you're going to do, but it's really important that in this section you really try and do your graphs as neatly as possible. If you have any questions, come in and see me early tomorrow morning. I'll be here probably about 7 o'clock. Otherwise, we'll see you in tomorrow. Bring your books. You'll need graph paper, a ruler, and a positive attitude, because we're going to be graphing some now for this chapter. There's going to be a lot of graphing. Thanks.